Today, I want to start calculus of parametric curve. I will talk about differentiating parametric curve. That is 7.2. Calculus of parametric curves. As I told you yesterday, parametric curve is defined by two parametric equations which define the points on the x coordinate and points on the y coordinate. Let's suppose that y is a differentiable function of x. Then what we want to think about is what is the first and second derivative. This is dy over dx. What we know is the coordinate y is defined by the function g, and coordinate x is defined by function f. So when we think about dy over dx, what we do is we just differentiate with respect to t for y and with respect to t for x coordinate. So we can formulate like a dy over dt over dx over dt. Of course, we are thinking about the fraction, so dx over dt shouldn't be 0. This is the first derivative. And the second derivative, which is written as d squared y over dx squared. This can be perceived like we are differentiating twice for, so ddx and then dy over dx, right? And we know that this is a function of t, and we can view this like dy over dx over dx. Therefore, we can think about the differentiation on the numerator and denominator. And so it goes like d dt dy over dx over dx over dt. So what should you remember? Just everything is the same, except you just differentiate the numerator and denominator with respect to t. This is the second derivative. And derivative for the parametric curves goes like this. Let's do the examples. Determine the slope of the tangent line. to the parametric curves. The first question is about the parametric curve defined by x of t equals 1 minus 2t and y of t equals 2 minus 6t at t equals 0. Then it is dy over dx. So at t equals 0. And so dy over dt over dx over dt. So dy over dt is we differentiate this part, then that is -6. Dx over dt, we differentiate this one, and then that is 2, -2. So that is 3, right? The second question is x of t equals natural log of 5t minus 8 and y of t equals 4 minus 10 natural log of 8t when t equals 1. So dy over dx t equals 0. And then I said you will differentiate dy with respect to t and dx with respect to t when t equals 0. And so dy dt, we differentiate this part, and this one will vanish, and -10 over 8t, so natural log, and then chain rule times 8 over this part will vanish and chain rule is applied, so 5 over 5t, right? When t equals 0. So obviously we have to simplify further. If we just put t equals 0 here, then denominators are undefined. So these two will cancel each other. So -10 over t times these two will cancel each other. This is in the denominator and this is 1 over t. So we can multiply the reciprocal. So t equals 0. So those will cancel each other. So that becomes -10. The next one is x of t equals 7 square root of 4t and y of t equals -5 square root of 5t plus 4 and t equals 1. So let's differentiate dy over dx when t equals 1. Then that is dy over dt over dx over dt when t equals 1. So this one will be, what is this? This part can be rewritten as 5t plus 4 to the 1 over 2. And so dy dt will be -5 times 1 over 2 times we are applying the chain rule. So 1/2 minus 1 will be negative 1/2 times the derivative of this part is 5. And then differentiation for this one is 4t to the 1/2 power. And so 7 is here times 1/2 times 4t to the this one minus 1 is negative 1/2 times differentiation of this part is 4. When t equals 1. So let's just plug in t. So 1/2 will cancel each other. And this one times this one will make minus 25. And then t is 1. And then 5 times 1 is 5 plus 4 is 9 to the negative 1/2. Over 7 times 4 is 28. T is 1. So 4 to the negative 1/2 power. This one is negative 25. And then this is 1/3, right? Square root of 9 is 3 and negative power makes a fraction. This one is 28. And then this one is 1/2. So this becomes negative 25/28 times 1/3 times 2/1. So that is negative 25/28 times 2/3. So these will cancel each other. So denominator is 14. Negative 25/52. So 42. The next problem is x of t equals negative 8 e to the 3t power, and y of t equals negative 10 e to the negative 10t power, and t equals 1. So dy over dx when t equals 1. And then dy over dt over dx over dt when t equals 1. So we are just doing the derivative. So dy over dt, we are thinking about this one. So negative 10 times e to the negative 10t, and then chain rule. And so we have to differentiate this part. And so negative 10. And then dx dt is a negative 8 times e to the 3t times differentiation of this part is 3, right? And so what can we do? This one is 4 and this is 5. And so minus will make plus. And so 50 e to the negative 10t, and negative 4 times 3 will make negative 12. E to the 3t power when t equals 1. So just so we can ignore t here. So the common factor is 2, so numerator is 20. 25 and denominator is -6. And here we have 1 over e to the 3t power times, this one is 1 over e to the 3 power, 1 over 10 power, e to the 10 power, because t equals 1. So that is 25 over -25 over 6 times 1 over e to the 13 power. The next one is x of t equals 3 times sine of 7t, and y of t equals -2 cosine of 7t when t equals pi over 4. So we have dy over dx when t equals pi over 4. So if you differentiate y, then that is -2 times cosine differentiation is minus sine of 7t. And then chain rule is applied 7. And t is pi over 4. And then 3 times differentiation of sine is cosine of 7t and chain rule. So we differentiate this, so 7. So these two will cancel each other, and minus will make +2 sine of 7 pi over 4 over 3 cosine of 7 pi over 4. So this is 2 pi, 0, 2 pi, 7 pi over 4 is located here. In that quadrant, the sine is negative and cosine is positive because x values are positive here and y values are negative here, and so sine is negative. And this one is 8 pi over 4, therefore pi over 4 is the reference angle. So we can rewrite that as 2/3 times sine is negative, so negative sine of pi over 4 over cosine is positive, so cosine of pi over 4, which is a reference angle. So what is this? This is -2/3, and the sine of pi over 4 is 1 over square root of 2, and cosine of pi over 4 is 1 over square root of 2. So this part equals 1. So we end up getting -2/3. Any question? The next one is find all points on the parametric curve with a given slope. The first problem is x of t is given as t plus 2 over t, and y of t is given as t minus 2 over t, and the slope equals 2. In this case, the consequence of differentiation is given, and we have to figure out at what time the slope becomes 2. The first step to do it is differentiating dy over dx. So as we have been doing, we will think about dy dt over dx over dt. So d dt y is t minus 2 over t over x is d dt t plus 2 over t. So we want to think about d dt and t minus 2 times t to the negative 1 power over d dt t plus 2 times t to the negative 1 power. Therefore, this one derivative is 1 minus 2 times this one minus 1 times t to the negative 2 power. Again, this one is 1 plus 2 times negative 1 t to the negative 2 power. So how can we simplify? That is 1 minus minus will be plus, so 2 times t to the negative 2 is 1 over t squared, and 1 minus 2 times 1 over t squared. So the common denominator is t squared. So the numerator t squared and t squared over t squared. So t squared plus 2 from here. And denominator, again, common denominator is t squared. And so t squared minus 2. So let me just go through all those. T squared plus t over t squared times this one is the denominator. And so t squared over t squared minus 2. So those will cancel each other. And then we have t squared plus 2 over t squared minus 2. So this is the derivative. The condition we have is the slope must be 2. So this number must be 2. So t squared plus 2 over t squared minus 2 equals 2. So we have t squared 2 plus 2 equals 2 times open parenthesis t squared minus 2. So that means t squared plus 2 equals 2t squared minus 4. So we subtract each. Let's do this one. And then those will cancel each other. So 0 equals t squared minus 6. So that means we have t squared equals 6. Therefore, t equals plus or minus square root of 6. So what am I talking about? When the time in parameter is plus or minus square root of 6, the slope at that point becomes 2. And so we identify the time, and then let's read the question. The question is find all the points on the parametric curve, which means parametric curve is embedded in the rectangular coordinate system. Therefore, we have to figure out what those coordinates are. So t is plus or minus square root of 6. So we start with t equals square root of 6. Then we to figure out x and y coordinate, we will use these equations. So x of square root of 6 equals square root of 6 plus 2 over square root of 6. So what is this? This one is square root of 6 times square root of 6 over square root of 6 plus 2 over square root of 6. So this one is 6 plus 2 over square root of 6. So that is 8 over square root of 6. I'm not sure whether it requires rationalization or not. If it doesn't, then you can just keep that like this. The next one is if, and then the x, now y equals square root of 6. So we have this formula. So that is square root of 6 minus 2 over square root of 6. So square root of 6 times square root of 6 over square root of 6 minus 2 over square root of 6. So that is square root of 6 in the denominator. So 6 minus 2 equals 4 over square root of 6. So x and y coordinates are 8 over square root of 6 and 4 over square root of 6. And so that is one point where the slope becomes 2. And there is another point. We will calculate that. So if t equals negative square root of 6, then from the given equation, x of negative 6 is negative square root of 6 minus 2 over square root of 6. So of course, I used this given formula equation. So that is minus square root of 6 over 6 minus 2 over no, it's so this is negative 6 over square root of 6 minus 2 over square root of 6. So that is minus square root of 6 in the denominator, negative 6 minus 2 is negative 8. The next one is y over negative square root of 6. That equals negative square root of 6 minus 2 over negative square root of 6. I used the given equation, the function t minus t, 2 over t. So this becomes negative. The common denominator is square root of 6. 6 over square root of 6 minus minus will make plus, plus 2 over square root of 6. So that is negative 4 over square root of 6. Therefore, we get the point negative 8 square root of 6 and negative 4 over square root of 6. So x of t equals 3 times sine of AT, and y of t equals -6 cosine of 8t when t is between 0 and pi over 8, and the slope equals -2 square root of 3. So again, the slope is given, so we have to think about the differentiation. First the derivative, and then we have to set up the equation and try to find t, and then we will figure out the coordinate. So we end up getting dy over dt, dy over dx. So that equals dy over dt over dx over dt. So dy over dt equals -6 times negative sine of 8t times derivative of this part is 8, and dx, so this is 3 times derivative of sine is cosine of 8t times 8. So those two will cancel each other, and then numerator becomes -2. Negative, that minus will make plus, so +2. And sine over cosine is tangent. So that is tangent of 8t. What they are saying is that slope is -2 square root of 3. Therefore, tangent of 8t equals -2 square root of 3 over 2, which is negative square root of 3. We have to figure out what t is. So we start with the equation. We obtained tangent of 8t equals negative square root of 3 over 1. This is negative opposite over adjacent. So we have to relate that with 30, 60, 90 degree triangle. So 1, 2, square root of 3. This one is opposite of pi over 3. So reference angle is pi over 3. And tangent is negative in second and fourth quadrant. And so I would draw this graph. So because tangent is negative, and we know that the reference angle is pi over 3. So what we calculated was indeed a reference angle of 8t, because we thought about what could be the angle a times t. And what we know is this is pi. The angle theta is indeed 2 pi over 3. So this angle, let me just write the angle 80 here. The angle theta is 80, right? So we have 80 equals 2 pi over 3. Therefore, we divide by 1 over 8. And so those will cancel each other. So t equals these will cancel each other. So pi over 12. And then we have to think about x and y, because we obtained value for t. But what they are asking us is the coordinate of the point where the slope is negative 2 square root of 3. So we have to calculate x and y value. So we have the angle pi over 12, and then we have to use this condition. So 3 times sine of 8 times pi over 12. So 4 times 3 and 4 times 2. So that is 3 times sine of 2 pi over 3. So what is that? I said the angle is here. And this is pi over 3. The reference angle is pi over 3. This angle is 2 pi over 3. And sine in the second quadrant is positive and cosine is negative. That's what we are using. So 3 times sine of reference angle pi over 3. That is 3 times square root of 3 over 2. So that is 3 square root of 3 over 2. And then we have to calculate y value. Y of pi over 12 equals negative 6 times cosine of 8 times pi over 12. So we are going through the same calculation with the same angle value. So negative 6 times cosine of 2 pi over 3. So we use the reference angle, but this time cosine is negative, and so negative cosine of pi over 3. So negative will make positive, and 6 cosine of pi over 3. So that is 6 times 1 over 2 equals 3. So the coordinate for that one will be 3 square root of 3 over 2 and 3. Let's do just one more problem for today. So in this problem, we calculated the coordinate where the slope at that slope of the tangent line is the given number. This time we want to figure out the tangent lines equation. The question is determine the equation of the tangent line at t equals 1 to the parametric curve x of t equals negative 5 e to the 2t and y of t equals negative 3 e to the 5t. Since we are talking about the tangent line, we have to figure out the slope by differentiating, and t is given, so we know the coordinate point the tangent line passes through, so we will use the point slope form for the calculation. So dy over dx at t equals dy over dt over dx over dt. So dy over dt is negative 3 times e to the 5t times chain rule, so 5 is multiplied. And the differentiation of x is negative 5 times e to the 2t times 2, right? And so those two will cancel each other. Minus minus will be plus. We are thinking about t equals 1. Therefore, we have 3 over 2 times e to the 5 over e squared equals 3 over 2 e cubed. So this is the slope, and we want to calculate the equation of the tangent line. So we have to figure out the x coordinate and y coordinate. X at 1 is 5 times e to the 2 times 1 equals negative 5 e squared, and y of 1 equals minus 3 times e to the 5 times 1 equals negative 3 times e to the 5 power. So it passes minus 5e squared negative 3e to the 5th power. And so we have slope and point, right? So we can think about the point slope form. So y minus 3e to the 5th power equals slope is 3 over 2 e cubed x minus 5 e squared. So that is y plus 3 times e to the 5th power equals 3 over 2 e cubed x minus will make plus. So plus 3 over 2 e cubed times 5e squared, right? So what can you do? So we have to subtract this one on both sides. So y equals 3 over 2 e cubed x plus 15 over 2 e to the 5th power minus 3 times e to the 5th power. So 3 is 6 over 2, right? So we can say, when we simplify, we have y equals 3 over 2 e cubed x plus 15 minus 6 will make 9 over 2 e to the 5th power. So I talked about a first derivative of the parametric equation today. Next week, I will talk about the second derivative of the parametric equation. We will calculate all those. Do you have any question? If you don't have any question, then you can leave